Welcome to Mastering Solutions. With this question, let's write down the equation first that we're going to be using for this. The book gives us theta is equal to P times lambda over A. So what do they ask us to find? We're trying to find the wavelength of light for this situation, right? P is the minimum, the order of the minimum that we're finding, and they say a second. So P in this case is going to be 2. And A, that's given to us. We have a 0.1 millimeter slit, so 0.1 times 10 to the negative 3 meters. And theta is given to us, but this is not a direct plug and chug. We do actually have to convert this. They give it to us as 0.7 degrees, but we need this in radians, not degrees. So to convert that, well, we know that for every 180 degrees, now the degrees will cancel, we have pi radians. And when we put that into our calculator, we have, make sure I'm in radian mode. Okay, so we have 0.7 degrees times pi divided by 180. And it's the exact same thing if I were to do 0.7 divided by 180 times pi. You can see exact same answer. And so that's going to be 0.0122. We'll carry it far. So 0.0122 rads. And we need to rearrange our equation a little bit. We're trying to solve for lambda, but we have it solved for theta. So let's multiply both sides of the equation by A. So we have A times theta is now equal to P times lambda. So if we divide both sides by P, now we have theta is equal to A times theta over P. Now we can plug all of our values into this, and lambda will be equal to A, which we said was 0.1 times 10 to the negative 3 meters. We're going to multiply that by our theta here, which is 0.0122 radians. And then all of that gets divided by P, which we said is 2. So we have 0.0122. If I plug this right in, we get a little bit more precise answer. I'm just going to leave our rounded one. And then we have times 0.1 times 10 to the negative 3. I need to add some parentheses here. Okay. All right. And then now that gets divided by P. And our answer is given as 1, 2, 3, 4, 5, 6, 7, 8. We'll go one more for nanometers. So the answer of the wavelength is 610 nanometers for the wavelength of light for this situation.